Ala yun, diba? Sa mga nagalit.
Testing. All right, testing. Can you all hear me? Clearly, I'm going to be echoing. So whoever is here don't need to join online. You know. Are you join? So you give yourself a while ago, you know. You remember the chose to the happen and the hack speed out. So not calling you out, I'm just saying. Online, if you can't hear me, let me know.
Can hear you.
You can't hear me?
Yes, sir.
Can't hear me. Good. You can't see me too?
Yes, sir, we're seeing you.
All right, great. Welcome. So did everybody go through the subnetting videos or anything for subnetting? From the time? The last time? The storm. No, I use that one as before the storm. I know that they're not coming. So I make sure me. Now wait for the answer then. I'm gonna ask you a question. The meeting is recorded still, so I'm scared to ask you that. But you have a girlfriend, right? So you did see her before this time or after this time, don't it? No. Now you tell. So you have to go to church Saturday or Sunday and ask for forgiveness. So after you come and cover your mouth, you know, so you're not telling the truth. So it's the same thing with the schoolwork. Time and place for everything, right? So just like what you have to see her, should I just go through it? But that's fine. So let's go through very quickly. Sure. Yes, that's fine. I'm going to try because I don't want to bore these people. So read what is on the board. What is the learning object? Anybody? Let's read it out. Why everybody participate? But I just come to talk about.
Learning objectives, network subnetting, network sub.
Let's go on to it. Yeah, go on good.
Network subnetting classes, subnetting calculation. Combination of gateways, and address assignment.
Good. All right, cool. Well, I know what to be in the way of this thing anyhow. It's 2 times I have this thing. So tell it. Good. All right, so everybody can see that. Good. All right. What is network subnetting? Or you can think about the general term subnetting, but what is network subnetting? Anybody? If you want Google answer, no problem. If you want ChatGPT answer, no problem. But what is Well, let's make sure you make it to your own. Tell me very quickly. Everything in 10 seconds, 15 seconds, please. What's the network subnetting? Any Champions League was played? No. Good. Anybody, somebody. Providing a larger IP network for smaller. Talk about that, that's one, I like to be here.
The process of dividing a larger IP network into a smaller, more manageable subnetwork. Subnets to improve performance, security, and other allocation efficiency.
Perfect. So you just said dividing what?
Dividing larger IP network into smaller, more manageable IP network.
It's done. So. Yeah. Oh. And that's a big artist, but this would consider as a large network. And you say what it does?
Here's what I did into smaller, subnetworks.
So, quickly. No, what in the rest of that's good. But this is a large network. Come develop this one. Think you can divide more? Eh? He didn't start, I give him more, I want the extra, still going. I don't know, somebody didn't stop, I was like. Right, good man, right. Alright, yeah, cool. So, respect our manners. Pick up yourself. So, it's dividing what?
Smaller networks.
Read that to me and make sure. Talk loud enough so them can hear online. So tell me if what him said makes sense to what that is.
Network community is the process of providing a larger IP network into smaller, more manageable subnetworks called subnets. It is a fundamental concept in IP networking that helps optimize network security and management using awesome background.
Is it what?
Awesome background. Oh, wait, remember, isn't there?
So here, what is what we call this?
IP address.
Good. I remember when you go through some of this, if when I was online with me the last time before Melissa. But this is an IP address /24. But what you call this /24? So you have two components to IP. You have IP address and what is the other component?
Subnet.
Finish it. Subnet what?
Subnet network.
Not the word I'm looking for, but subnet what?
IP address.
No, you go far down.
Subnet what?
No, you're gone too far again. Nobody know on a KFC. Subnet. Say it again. You know I'm a rate you? And you wear makeup and mask when you go to your school, don't it? So pick up yourself. So she right. Subnet mask, right? So /24, which what they call a subnet mask. So this will translate to 255.255.0 actually. So it's the same as /24. We won't get into all of that people. I just want to give you an example. So this is an IP address that will be given to you all, or given in the lab here, but this has to be broken down into what?
Subnets.
Or smaller segments, which is what you call subnets. That's correct. So, for example, yeah, go ahead. Ask me anything if you want. Online, I'm not reading the chat, but if somebody can monitor it, just. So this is not the camera, what them can see. All right, so let me turn on my camera then, which we never want to look at more. I go things I'm gonna wash my face. Online, you can see that board? Somebody on the mic can tell me, you can see the board?
Paulos, you may need to zoom in a bit.
Huh?
You need to zoom in some more.
Oh no, we can't zoom in, hush.
Or adjust the
Just
camera
carry
to
the camera
one side.
closer, but I'm going to try and make the most of it.
Yeah.
And I never came other tool that I could have transcribed what's on the board to zoom. But so we'll get this big address and we have to break it down into HR, IT, research and development, finance, which other sections in our workplace. Well, yeah. Engineering department. Just for example, so everybody has to get a piece of that big address. And it's going to be subnetted that. And why we do that? Why we give out of this big address, we give each of these departments a part of the address? Why we do that?
So easier to know.
One, easier to manage, not an oval. Yes and no. But I see where you're going. But it's easier to manage, and so whoever is a network person, when something happens in HR, it's easier to administratively.
No, it's
You know it's HR. All right, cool. All right, why do we need subnetting? What the first one says? How we reduce network congestion? I'm going to give you one. No, but I'm going to give you one. So what's one of them there? Large networks create excessive broadcast traffic. What's the next one? Subnetting limits broadcast domains. I hope you know what that is. And an example is without subnetting, a broadcast can be sent by one computer and it reaches what? Everybody. But as we said before, in a case like this, now, properly. But this is the camera I'm supposed to see me too. Because, so 1 second. You know, after the picture, I'm send the presentation I'm done. And kill up yourself and full up the phone storage. You know, for that one.
Sir, yeah, see better now? Sir?
I'm not seeing the board.
Wait there. This can you, sir? Yeah, see now?
Better, but it's too far now. Zoom in.
Are we?
Yes, you can move the camera.
Come again, sir?
Still too far away.
Yeah, see now?
Better, but I don't know if it's. I'm gonna bring on my computer so you can see what I'm seeing.
No, me I see. Hold on. Finitors. So wait, what exactly you want to see? The two said?
Yes. Yeah.
But he's not sure.
All right. Thank you, my darling. So as I said, because if we never have subnet, when I send something, it's going to go to what? Everybody. But what if I want to send something just to IT department? I can do that because I have the subnet for IT. I know where to send it to. I can direct it. Yes or no? Yes. All right, good. What's another reason why we need subnet? It's four of them are given us the eh? Yeah, it is harder to have. Or you make it more difficult to have. But you see the second one is what? How you improve security.
I mean, I think you just spoke it, but that's something to spread it.
Good, I like that one. Isolate departments or control traffic between. And here's an example again. HR department can be separated from the general office network. So as you said, if I was trying to hack accounts from get where the money is sent from, it's maybe a little bit more difficult because finance is on a different IP address, or I mean a totally different what we call VLAN. Remember what we spoke, LAN is what? And when you put a V before, what it becomes? Good. So when you break down these and segment them, it actually becomes a virtual LAN. Because it's not like you physically. You understand me? What's the third one? Optimize. Why we optimize it?
Yes, IP address usage.
Good. You did this before, right?
Presentation I use.
Eh?
Presentation I use.
Oh, so let's see, I'll go through them. So efficient allocation of IP addresses. So even though this is a broad address, there might be only 15 people in HR, 10 in IT, 8 in You understand me? 12 and maybe 20 in engineering, for example. So when I break down this address, and you're going to see all of that, and we're going to get to that very quickly. I might only need an address for how much persons in finance. So I'm just going to get one that is exactly 12. Suppose, what's his name? Philip. Suppose Philip now leave HR, I said too much fruit in HR, say one transfer and go over to finance. You understand me? So, finance will then become how much now? 33. So I'm going to give an IP address only for 12 people because I want to do what?
It's fine.
Good. So you want to give an IP address of maybe a maximum of how much in this case?
30.
Oh, that's already fine. Maybe about 20. Just for in case of expansion or there's a device I need to add or so. So you don't want to maybe put the one for engineering in R&D because engineering will have a bigger IP address pool because it's a bigger size, right? So efficient allocation of IP address. Again, preventing, which are just experts. And a small branch office doesn't need thousands of IP addresses. I've gone to places and seen that. Right? When you have so much IP address, oh, they bought them. We never used to buy so much with 150 people, and what they bought was almost 4,000. So I can manage 4,000, and they weren't even going to expand beyond 300. So yeah, so yeah, again.
No, it wants it to say the projection, it wants everyone else the projection as well. Because at this angle, it's not getting the projection.
So when there's something else against that, not a person will come. But like you're saying, the efficient use of resources. Beautiful.
We just want to bring camera on. Just so
Now what because as I say, it's only 4 of them I'm sharing why you need something else, but it can be more. But I'm just sharing only 4. What is the 4? What is this the 4th one? No, but you have a black the projector. Simplify management, like I said it earlier. For us as administrators, you want to be able to manage quickly because you want to be time effective and efficient, right? So, what it says, easier to. Did you mention that earlier? Better organization of.
It's still me.
Another example was different subjects for different floors in a building. How subnetting works? Hope you can all hear this figure.
Ever wondered how large networks are divided into smaller and more manageable pieces? Or how IT professionals ensure efficient use of IP addresses in massive organizations? You're in the
Can you hear that? It's a sound.
Are they low?
Yeah.
Where's the point now?
Not sure, because the camera is here.
Okay. Yeah, it's better. Give me 1 second for while then tech team working on that. You can't hear that, right? So why not doing that?
right place. Welcome to Whiteboard Doodles, the channel where we simplify tech-related concepts using whiteboard animations.
You can't hear us? You can't hear it. I'm not hearing it. I went there with that.
Ever wondered how large networks are divided into smaller and more manageable pieces, or how IT professionals ensure efficient use of IP addresses in massive organizations. You're in the right place. Welcome to Whiteboard Doodles, the channel where we simplify tech-related concepts using whiteboard animations.
Are you still hearing it online? Oh, good. Well, you can't hear that any better? Oh.
Today, we'll break down the concept of subnetting, showing you how networks are split into subnets to optimize performance and security. Let's dive in. First, let's take a look at what subnetting is. Subnetting is the process of dividing a larger network into smaller, more manageable subnetworks or subnets. By breaking
So I just wanted to watch this. I listened about 10 minutes. So I only have 2 videos, one shorter than one, but this will capture everything. So I have to make notes, because some questions will come up on this right after this. So now have to watch it very carefully and make as much notes as you can. That's madness, I guess.
Ever wondered how large networks are divided into smaller and more manageable pieces? Or how IT professionals ensure efficient use of IP addresses in massive organizations? You're in the right place. Welcome to Whiteboard Doodles, the channel where we simplify tech-related concepts using whiteboard animations. Today, we'll break down the concept of subnetting, showing you how networks are split into subnets to optimize performance and security. Let's dive in. First, let's take a look at what subnetting is. Subnetting is the process of dividing a larger network into smaller, more manageable subnetworks or subnets. By breaking down a network, subnetting helps organize and efficiently allocate IP addresses, preventing waste of IP resources. It enhances network performance by reducing traffic congestion and improves security by isolating different parts of a network. Subnetting also allows network administrators to better manage and control access within different areas of a network, making it easier to troubleshoot and maintain. Each subnet operates independently, yet remains part of the larger network, ensuring efficient communication between devices. Now let's briefly take a look at IP addresses and subnet masks. An IP address is a unique numerical label assigned to each device connected to a network, allowing it to communicate with other devices. It's essentially the digital address that helps identify and locate devices within a network or across the internet. IP addresses come in 2 versions, IPv4, which consists of 4 sets of numbers, and IPv6, which uses a longer format to accommodate the growing number of devices online. Subnet masks, on the other hand, are a crucial companion to IP addresses. They determine how the address is split between the network portion and the host portion. A subnet mask consists of a sequence of numbers, typically written in the same format as an IP address, that tells the device how much of the IP address belongs to the network and how much is reserved for the individual device. For more in-depth information on IP addresses, be sure to check out our separate video covering the topic in the video description. Expanding on IP addresses, let's take a look at IP address classes. IP address classes are a method of categorizing IP addresses based on their range and intended use, providing a structured approach to allocating addresses within a network. The primary classes are Class A, B, C, D, and E. Class A addresses are designed for very large networks, allowing for up to 16 million hosts, making them suitable for major organizations and ISPs. Class B addresses support medium-sized networks with up to 65,000 hosts, ideal for universities and larger businesses. Class C addresses are typically used for small networks, accommodating up to 254 hosts, making them common in smaller offices and home networks. Class D addresses are reserved for multicast groups, allowing a single packet to be sent to multiple hosts simultaneously, useful in streaming media and conferencing applications. Finally, Class E addresses are reserved for experimental purposes and research, often used in advanced networking protocols. Understanding these classes is crucial for efficient network design and management, allowing network administrators to allocate IP addresses according to the specific needs of their networks. The range between 126.0.0.0 and 128.0.0.0 includes IP addresses which are part of Class A but are primarily reserved for loopback addresses, allowing applications to communicate with the host without requiring an external network. The most commonly used address in this range is 127.0.0.1, often referred to as localhost. Now let's take a look at basic subnetting calculations. For subnetting, we need the original IP address and the subnet mask. Suppose we have the IP address 192.168.1.0 and the subnet mask 255.255.255.0. To begin, we convert the subnet mask into binary. If you're unfamiliar with this process, we recommend checking out our separate video on binary linked in the description. The subnet mask in binary reveals the division between the network and host portions. In this case, the subnet mask translates to 24 ones and 8 zeros. The number of zeros in the subnet mask determines the number of possible hosts. The general formula to calculate the number of possible addresses in a subnet is 2 to the power of n, where n is the number of bits allocated for the host portion. In this example, there are 8 zeros, so the number of possible addresses is 2 to the power of 8, which equals to 256. However, not all of these addresses can be assigned to devices. The first address in this range is reserved for the network ID, which identifies the subnet itself, and the last address is reserved for the broadcast address, used to send data to all devices in the subnet. This leaves us with 254 usable IP addresses. Additionally, it's important to note that the more zeros in the subnet mask, the more hosts can be supported within that subnet. Conversely, a subnet mask with more ones means fewer hosts but more subnets. The number of subnets can be calculated using the formula 2 to the power of m, where m is the number of bits borrowed from the host portion to create subnets. In our example, no bits were borrowed, so the network has only one subnet. If we were to borrow bits, it would reduce the number of hosts per subnet but increase the number of subnets, allowing for a more structured network layout. Now that we understand the basics of subnetting, let's dive into how to read and interpret it. Reading and interpreting subnetting requires identifying key elements like the network address, broadcast address, and the range of usable IP addresses. A common way to represent this is through CIDR or classless interdomain routing notation, which combines the IP address with a suffix that indicates the number of network bits in the subnet mask. For example, an IP address of 192.168.10.15/24 tells us that the first 24 bits belong to the network portion, leaving 8 bits for hosts, since there are a total of 32 bits in an IPv4 subnet mask. To determine the network address, you set all host bits to 0, giving you 192.168.10.0 in this case. The broadcast address is the address where all host bits are set to 1. In this example, it is 192.168.10.255. The range of usable IP addresses falls between these two values, starting from 192.168.10.1 to 192.168.10.254. CIDR notation helps quickly identify how the network is segmented, making it easier to organize and allocate IP addresses efficiently. Now let's explore some common subnetting scenarios that network administrators encounter. When working with subnetting, several situations arise that help optimize network performance and management. One prevalent situation is dividing a large corporate network into smaller subnets to enhance security and reduce congestion. For instance, a company might separate its administrative, engineering, and guest networks, ensuring that sensitive data remains protected while allowing for efficient traffic management. Another common scenario involves allocating subnets based on geographic locations, enabling remote offices to communicate effectively while maintaining separation from the main corporate network. Additionally, organizations often implement subnets to accommodate growth. As the number of devices increases, they can easily create new subnets without overhauling the entire network structure. Lastly, internet service providers frequently use subnetting to manage their IP address space effectively, distributing ranges to customers while ensuring optimal utilization and avoiding address wastage. These scenarios illustrate the versatility and necessity of subnetting in modern network management. As we dive deeper into subnetting, it's important to understand the differences between classful and classless subnetting. Earlier in the video, we covered the different IP address classes A, B, C, D, and E, which are central to classful subnetting. In this system, IP addresses are divided into these fixed classes, each with a predefined subnet mask, limiting flexibility in allocating address spaces. This rigid structure often led to inefficient use of IP addresses, especially for smaller networks that didn't need the large number of addresses assigned by the class system. On the other hand, classless subnetting, known as CIDR, which we discussed in a previous chapter, allows for more flexibility by letting you choose any number of bits for the network portion of an IP address, rather than being confined to the fixed class ranges. This flexibility helps allocate IP address space more efficiently, minimizes waste, and improves network scalability by allowing organizations to create subnets that fit their specific needs. CIDR also enhances routing efficiency by reducing the size of routing tables, making it the preferred method in modern networks. When managing IP address allocation and subnetting, it's crucial to be aware of potential pitfalls and adhere to best practices to optimize network performance. One common mistake is neglecting to document subnet configurations, which can lead to confusion and inefficient management, especially in larger networks. It's essential to maintain clear records of assigned IP ranges, subnet masks, and the purpose of each subnet. Another pitfall is failing to consider future growth. Organizations should plan their subnetting with scalability in mind to accommodate potential expansions without readdressing the entire network. Adopting a hierarchical addressing scheme can enhance routing efficiency and simplify network management. Additionally, regularly reviewing and updating address assignments helps avoid conflicts and ensures optimal utilization of IP address space. By following these best practices, network administrators can minimize errors, enhance performance, and ensure their networks remain flexible and manageable. In conclusion, understanding subnetting is crucial for optimizing network performance and efficient IP address management. By grasping the fundamentals of subnetting calculations, interpreting CIDR notation, and recognizing the differences between classful and classless systems, network administrators can design networks that are both scalable and efficient. Additionally, adhering to best practices, such as thorough documentation, planning for future growth, and regular reviews, can significantly reduce errors and enhance network performance. With these principles in mind, organizations can ensure their networks remain robust and adaptable to changing needs. This concludes our exploration of the basics of subnetting. If you enjoyed it, consider subscribing to our channel and like.
That makes sense? Or was that a lot? Alright, was confusing? It was? Alright, so you saw the table that we showed a while ago, the different classes. So class A go from what?
1 to 6.
Good. So this address that's on the board, which class it falls in? The one that have on this example there.
Class this.
Whoa, you said who's the class A? Alright, you said class A. Who else? Who else said class A? All of you. Vote online if you want to do that. Can show a raise hand, but who's the class A? Let's hold up your hand. You said earlier, so you have to hold up your hand. I'm gonna have dreadlocks too now, I'm gonna cut my own. So you can't let me down. Who is the class A? On that side of the bench. Alright, class B. Class A. Alright, who's the class B? Everybody have to answer now, so we'll get 2 class A. Who's the class B? Hold up your hand if you say class B. Alright, who's the class C?
Class C, sir.
Well, all the class C people, please stand up.
I want to that I 192. 192. 192. 192. 112. Let's go 192. 192. That's fine. So even for 112, 112. 1 plus 8. Oh, yeah.
So fine, you tell my penmanship bad, but cool. So this is a class. A lot of times, most of the addresses that you all have at home is class C. Even right here, whatever they get as the IP address. What's the IP address on your computer? Eh? You're not sure? So you don't find it. No, I'm not going so far. So go to command line. So just go. And just write CMD, CMD. And just type IP config R. IP config one word. IP config power slash space power slash. No, slash. Then Number 8 now. And it says IP address for the Wi-Fi user, right? And the IP address 10 now. So tell me what your IP address is at the computer that you have right now. So tell me what you have?
10.29.
10.29
dot 175
.101. That's the address you have here right now. And that slash, what's the subnet mask?
225. 225.
Hold on. So that is 225 dot.
Oh, no, sir, you get 255.
Okay,
255.
good. Who online? Who else online? You can hear me online?
Yes, sir.
You still can hear me online, right?
Yes, sir.
25. Okay, good. 255
Dot 255.
dot 255
Dot 255.
dot 255
0.
dot 0.
Yeah.
Eh? You're not gonna have that. If you have that, something wrong. Not better, it's not a matter of better, but if you have that, that means it's a conflict, and you should never have the same thing. So this is slash what? Like when you have slash 24 that translates to this, this would be slash what? Huh?
There's no slash.
There's no slash? There is. We have to work out what the 255 relates to. But you're going to see that in the other video very short. Because you might think that one doesn't have, there's another video that will answer your stuff. So this class IP address is what though? A. So that means X said in the lab here is using a class A. Is that a public or a private IP address?
Private.
Okay, good. Let's keep on moving quickly. As time is going. So this is a class C example, which was a 192.168, which we had earlier here, so right? 255.255.0. It says to create 4 subnets. Anybody can do that?
From the main register.
From that address. Anybody know how to do that?
192.168.1.2.
That's the address, you know. I need to create 4 subnets from it. Anybody know how to do that? You soon see all of that. I just want to see. Or where soon work with all of that. So that's class C. So that's what the 4 going to look like. That's when you're going to work with all time 7. Class B, that's an example of a class B address because it falls within. Remember the range?
Yes.
You might get that exam here. And that's to create 4 using that same formula. That's the 4. So we're going to work out all of that. I don't know to be there. That's the 4. And then class A here is because class A, would that represent the address like this what you have here in the lab? Yeah?
Yes.
VLSM stands for Verbal Lex Subnet Mask. Anybody know what that is? Somebody research that for me. DLSM and tell me what it is quickly.
So
Go on, what?
description for
I want to what yeah, what it is, what does it do, what it is, what it is.
the technique for dividing the network into subnets of different sizes. Use IP addresses more efficiently.
Really, that is know that's a technique that what?
It's a technique for dividing a network into subnets of different sizes to use IP addresses more efficiently.
Good.
Sir. Sir.
Yes.
I mean, I see it in both, sometimes you get different description.
That's fine.
Alright, so this one say it's a method of subnetting a network in different size subnets itself, making all subnets.
Same thing. But you understand it that way better? Or the first one what you gave was what? So the IT is how much? 50? 50 holes. Them have sales as how much here, so?
25.
25, what else? HR is,
10.
and admin is 5. Remember what we did draw earlier? Remember this? And what we did with this? Right?
Be right to.
So
Yes, sir.
so this would have be like IT, yes or no?
Yes, sir.
This would have be what?
Yes,
This would have be?
sir.
And this would have be? Admin in this case. Sorry, this one goes up there. No, no, right. Good. So we're going to learn how to break that down, the address that you see there. We'll learn how to
The word.
into the 4 subnets. So watch this video now. Notice what the title says. See if you can understand this. When you see the question at exam, murder. Mr. Rose tell you. I finished that exam in, make him tell you if I finished that exam. Because I knew what questions were coming from. I saw the questions that was good. From I learned this cheat sheet, I never had any question. And ask you how much I did get.
Hey YouTube, welcome to the IPv4 Subnet Mastery video series. This video is the keystone of the series. In video 3, we will learn how to use a cheat sheet to solve subnetting problems. These are the 7 attributes of subnetting. Every subnetting question will require you to solve for one or more of these 7 items. If you want to know what each of these items are, please check out the first video in this series. This is the subnetting cheat sheet. We will use this table to solve any subnetting problems. If you want to know the 3 steps to create this table, please check out video 2. In this video, we will show you how to use the cheat sheet to solve all 7 attributes for any combination of IP address and mask in 60 seconds or less. Our first example problem will be 10.1.1.55/28. We will find all 7 attributes for this IP and mask. We will start by learning how to quickly convert from CIDR notation to subnet mask. Our example problem provided a CIDR notation of /28. We will use that to find our column in the cheat sheet. Since we were given a /28, this puts us in this column. Within our column, the CIDR row will map to the subnet row. The CIDR notation /28 will map to the subnet value of .240, which means our subnet mask will be 255.255.255.240. Next, we will locate the group size. For our problem, with a /28, the group size will be 16. Then we will start at .0 and continue incrementing by the group size until we pass the target IP. So we will have .0, .16, .32, .48, .64, and at this point we've passed our target IP of .55. The .55 would exist somewhere between these 2 numbers. What we just did was the hardest part. From here, we can simply fill out the remaining attributes. The number before our target IP is our network ID. This makes our network ID 10.1.1.48. the number after our target IP is our next network. This makes our next network 10.1.1.64. The IP address before our next network is our broadcast IP. This makes our broadcast IP 10.1.1.63. Just like that, we were able to easily solve for 3 more of the 7 attributes. Solving for the last 3 will be just as easy. To find our first host IP, simply add 1 to the network ID. If .48 was our network ID, then our first host must be 10.1.1.49. To find the last host IP, simply subtract 1 from the broadcast IP. If .63 was our broadcast IP, then our last host must be 10.1.1.62. Finally, the number of IP addresses is very easy. The number of IP addresses is the same as the group size. For our /28, the number of IPs is 16. Keep in mind, this is the total number of addresses. Remember that the network ID and the broadcast IP are not usable addresses. So if you're trying to solve for the number of usable addresses, don't forget to subtract 2. For our /28, we would have 14 usable addresses. We will run through the same process with another example problem. This time, we will solve for all 7 attributes for the IP and mask 10.1.1.37/29. As before, we will start with converting between CIDR and mask. We were provided a /29. We will use that to determine that we are in this column. The CIDR and subnet mask rows map to each other, so we know that a /29 maps to .248, which gives us a subnet mask of 255.255.255.248. Then we will locate our group size, which for this problem will be 8. As before, we will start with .0 and increment by the group size until we pass the target IP. .0, .8, .16, .24, .32, .40. We've now passed the target IP, so we can stop there. .37 will exist somewhere in here. Once again, this was the hard part. From here, we can just fill everything in. The number before our target IP is our network ID. This makes our network ID 10.1.1.32. The number after our target IP is our next network. This makes our next network 10.1.1.40. The IP address before our next network is our broadcast IP. This makes our broadcast IP 10.1.1.39. To find the first host IP, we simply add 1 to the network ID. If .32 was our network ID, then our first host IP must be 10.1.1.33. To find our last host IP, simply subtract 1 from the broadcast IP. If .39 was our broadcast IP, then our last host must be 10.1.1.38. Finally, our group size was 8. Therefore, our total number of IP addresses was also 8. As before, if we were trying to find the usable number of addresses, we would simply subtract 2. There you have it. That is the process to solve for all 7 attributes using the cheat sheet. As with anything, this will take some practice. The next video in the series provides 4 more practice examples. 2 of them will be easier problems, and the other 2 will be a little trickier. Once you've watched both video 3 and video 4, you'll have a solid understanding of the process, and you'll be that much closer to becoming a subnetting master.
Was that any easier?
Yes, sir.
Alright, so you guys can research that for me. I want somebody online, so each person online take one of these for me. Let me see now, who are my participants? So Davis, take A for me.
Sir, so do you just real quick?
Oh, you're there here. We're online. So if I call your name and you're in here, no problem. Macintosh,
Yes, sir.
you're there. You want to just take one of them, yeah, man. And then you're going to give me the definition of each of them. So check DHCP. I think you did give me the answer for that already. But give me the one for version 6 then.
Version 6.
Yes, so take B, fill it, take A, you take C, take D, E, and my good friend right here in our blue jacket, take F for me. So I will leave that up. All right. So, sorry, right down here. So remember this address before, so this is what we call the IP address, right? And this is,
Subnet man.
or what they call it,
That's the idea.
right? Which is where work out, right now. We know. Oh, we know, start learning. I'm not to move that. Basically, done after this, because this is the trick of the whole thing. So 1, 2, 3, 4 is what we call octets. Why is it an octet? What is oct? 8. How much zeros here, so?
8 in a year for each step.
How much here, so?
Yeah.
So it's 8 in each line, right?
Yes.
Make sure I get that straight. How much octet is this? In this address, how much octets it is?
3. 4.
4. How do you get 3?
I've never seen one that rare decision.
Yeah, that's why I'm trying to put that space. Now for this, 192, no one octet that.
Yes, yeah.
Dot 168, no 2 octet that.
Yes. I use.
Eh? All right, so what the first octet? Now try to understand. Oh, you want me to do it this way? Okay, all right, no problem. You understand it that way? No problem. So this is the first octet, right?
Yes.
Is this the second octet?
Yes.
Which is 2? Is dot 50 the third octet?
Yes.
And then that one is the fourth octet, right? So the first octet is eh? 192. But before I do that, when I add 64 to 128, what I'm supposed to get here? 1?
92.
64 plus 128?
192.
Eh? When you add 64 to 128, what I'm supposed to get in this box?
172. No, 192. 192. 190.
Jeez.
192.
Let me calculate fast.
That's that. You want to do another?
192. When you add 32 to 192, what you get?
Now, and both of it's very consistent.
Yeah.
224.
224?
Yeah.
Sure?
Yeah, 120 plus.
What?
Yes, sir. 120 plus 32, sir.
192 plus 32.
Yeah, 224. Yes, sir.
Right, sure. Plus 16, how much?
240. Yeah, 240. 240. 252. 254. 246. Then 255. 54. 255.
Who said 2?
256.
252 plus 2. Okay. And then plus 1. So let's see that. Make sure to see it, you know. So in the exam, first thing I did was to do this same exact thing.
Hold on there.
All right, so 128.
Sir. Exam?
No, no.
Fine.
We're going to get a question that says, using this address, that is going to come in the exam. using that this exact thing, but if you get a question that says you are given this address, break it down into all these 4 departments. Remember the question that we asked before? Remember the first the slide? Yeah, I told you. You remember this? What was the requirement? That's actually going to be an example. I'm not asking you, I'm telling you. So you can't say I never tell you. You go and get the address and say that is the address. As a matter of fact, I even have this here. That's the one I use. But you can get a question like this that says you have the following address, which is 192.168, which we have up there. How many total bits are being used to identify the network? How many total are being used to identify the host? And it's going to ask you to break down and create 4 subnets. It's going to ask you that. You have to allocate that IP address into the 4. That's why I showed you the 2 videos, and I want to show you this because it's going to be on the exam. So what I normally do is I get a rough paper, I write out 128, 64, 32, 68, 421. Each of these, that 128 represents this first 0, 128, 64, 32, 16, 8, 4, 2, 1. Watch me now. For me to get 192, what I had to add?
Don't be 64.
So all of this use up, right? So all of this first one use up, don't it? So I start again. 128, 64, 32, 16, 8, 4, 2, 1. So if all of this is 128, and I need what?
190.
How much? How much of these? These are what you call bytes, the zeros. And in binary, you have 2 things, 0 and
1.
okay, good. How much I have to take from over here, so to get 192?
3, sir.
3 of them?
Yes, sir. That's the following of the 32. Yes, sir.
Fall under the 32.
Yes, sir. The third bit, sir.
So when I did add 128 to 32, how much I get?
Oh,
When you add 128 to 32, how much that?
correction.
Eh?
60%. Correction.
So if I want to get to 192, 128 plus what? Give me the 192.
64.
So how much I have to go over here, so how much of the zeros I have to take to make 192? 2 of them. So that means now this dead, all of this dead, don't it? And then I have to take 2 over here, so no so. And that's gonna make 192. I hope we're not following. Make sense?
Yes, sir. Yeah, all right.
So that means I can't use nothing more out of these, don't it? So I have how much out of this thing?
6.
Plus the rest of these, don't it?
Yes.
So 6 plus how much these? Plus 8 plus 8.
16. 16 around 16.
So 192 accounted for, so that's dead. Is that network or host?
Network.
Why? You're correct.
Somebody get that subnet ID.
Not necessarily, but because I can't use no zeros from this anymore, it now belongs to the network. The host is going to be only the zeros that I cannot, that are available to me. So that means, as I said, now 6 zeros leave plus 8 plus 8. So all of these other zeros are available to me as it stands right now. Yes or no?
Yes, sir.
All right then. 168. What will add up here, so to give me 168? 128 plus what? Then give me 168.
Very good. So,
No one I guess, man. Tell me, use on the calculator and tell me.
third, the 34 and the 8.
32 and the 8.
Yeah,
Then give me 168.
yeah.
32 plus 8 are how much?
40.
40. So it will give me 168.
4 plus 6.
Eh?
40 plus 20, yes.
Alright, so let's go take it now. 128, right?
Oh,
Plus 32. 8 plus 2 how much?
30.
Carry 1. 3 plus 2 plus 1 is what?
6.
And 1 plus 0 what?
1. Then add the 8, add the 8 I need.
So what we really actually use?
Oh,
We never use
oh,
we never use
so we use 3, so.
no so.
Yeah.
So then them three I'm use 128, 32 and 8.
Yes.
But I don't want to confuse them because then I can get confused.
Oh, so that's your reference.
So if we need use one, but I don't want to do that way. Let me do it another. Let me do it that easier way. Eight plus 8 is how much?
16.
Plus 8.
24.
Do this. Good. 8 plus 8 is
53.
16 plus 8.
24.
24 plus 8.
32.
Alright. Okay, 1 minute 7 4. Bro, one, killing the sun feature. About 1, 2, 3, 4, 5, 7, 8. Let me see, 30. 2, yeah. So 8 plus 8 is
16.
plus 8.
24.
So replicate this. This would have been the same 128 underneath here, so don't it? 128, yes or no? 64, 32, 16, 8, 4, 2, 1. If I want to get, and then I want them to say, oh, I got 255. When you add up everything here, so what you get? 255. When you add 128, 64, 32, 68, 4, 2, 1, what you get?
255.
So this now becomes 2, 5, 5, don't it? That, when you add up everything here, so that, this makes it 8 plus 8 is what? 16 plus what? So that would have been slash 24. Which therefore then means everything up to here, so can I use it or I cannot use it?
Yeah.
I cannot. Why?
Like network user.
Because the network have it. So the only thing I have available is the one, which is that means everything from here so to here, so dead for me, don't it? So all I have leave is what? These 8 zeros. That is what going to be used for the host. So remember, the first part would be the. Don't forget that. And anything that's available now becomes the. So all of these will be 1, 1, 1, 1, 1, 1, 1, 1, but now I mark it out because I want so and so. If I want to get /25, how much over here so I have to borrow? How much of this? Come remember now. This is 8. How much 0 is? 8. Plus 8 give you what?
632.
I'm gonna add 8 plus 16 over.
24, 34, sorry.
You know you're hungry, we're soon done, That's why you get 24. So I need 25. How much zeros I have to borrow over here so we get 25? Eh? 1. This one, don't it?
Yes, sir.
And this is 128, right? Yes or no? When remind each of them is each 0 is 128. This is what?
60.
This is what?
60.
Good. So all right. Oh, go back again. 255, 255, 255. For /24, being that this is being used, this will then become what? Now that's 0. Because we are using the whole of that, don't it? So now what would be it? So when you say /24, what will be the subnet mask for /24? Yes or no?
Yes.
So this /24 actually work out to be 2. That. So anywhere you see that, you know say is /24. So when you see this /24, you know this it said 255. So if this wasn't there and it's /24, we're supposed to cast it. We know the subnet mask. Out of the top on it. Yes or no? And then let's see how we get it. If I want to get /25 now, what we say we'd have to do over here, son?
Take 1.
Take 1. But this would have been the 25th one, don't it? Yes or no?
Yes.
This first 0 corresponds to what up here? Son? 128. Everything else, bam. So what is the subnet mask for /25? That?
1. 255.
That?
255.
That what?
1.
Wanna see it?
Okay.
Tell me if you wanna see it, you know.
See, sir. So that means if you take the other 0, that in the 63.
Hold on now.
Barn
/26 now. How much 0 over here? So I have to go bar now to get /26.
Another 0.
So for example now. That 0, right?
Yeah.
This is my big dot 0. I need 26. 24 plus how much will give me 26? So that means I have to go borrow how much zeros over there so I get 26. So we have to borrow them 2 here, don't you? This is now 26, yes or no?
Yes.
What was this first 0 again?
138.
And then second one is what?
64.
But when we add the 2 of them, how much we get?
93.
So that means what is now my /26 is going to be what?
255. 255. 192.
Then we want to see.
So you know, me have the brain I try if I'm battery reconditioning like this.
Make sure you get it. I'm going to just add that thing.
I try deepen free beat. Even though I'm not learning.
If I want /29, 24 plus how much I will give me 29?
5.
5?
Yeah.
So that are the 5 zeros now for bar over here, so don't it?
Yeah.
So this is the first one. This dead, right?
Yeah.
So that's our 25?
36.
26,
27.
27,
Master, I need to
28,
29.
29. So this is what? 128 plus
64.
plus
32.
plus
16.
plus
8.
and all that equals to what?
248.
So slash 29 where we what?
248.
Tell me if you want to see it now, man. Now see the mathematics.
Yes, sir.
So I get that now. So if you see an address that say slash 29 here, so regardless of what the first part of this is, but it says slash 29. What is the subnet mask for slash 29?
255. 255. 240. 240.
If it was at 31, what is the subnet mask?
255. 255. 255. 254.
25?
4.
I'm sure I said
252. 254. Oh, wait, sir. 31.
31.
254.
So watch me now. How much 24 plus how much I'll give me 31?
60.
So,
Oh, 7.
so we can count now. That's first zero and then, right? Then first zero and then, right? So 1, 2, 3, 4. So it's at 25, 26, 27, 28, 29, 30, 31. No, so.
Yeah.
So this is our 128 plus what?
164.
Plus 32, plus 16, plus
8.
plus
4.
plus.
2.
How much that add up to?
2. 5.
You sure?
Sir, sure.
So we just want to see the mathematics. So if we see a slash 31, we know say the subnet mask are 252. So they get that now.
Yes, sir.
All right, the tricky part now. We have this address. Originally, this address was a slash what? Based on the examples. The example here.
24.
24, right? And it asks us to create.
4 subnets.
And these are the four subnets. IT. How much percent in IT?
52.
How much in sales?
25.
How much in HR?
10.
How much in admin?
5.
All right. The next part of this was what? So it said, bits needed. 2 to the 2 equals 4 subnets. Yes or no?
Yes, sir. That was very useful. Because
So that's the formula. To find out how much need is 2 to the n. And n represents the number of subnets. Correct. And in this case, they wanted how much subnets in the question?
4.
4. So it's going to be it's 2 to the n. What? So n going to represent what? Eh? So n in this case is the equals to 4. There you go. 2 to the. You sure? 4 subnets in the one. 2. So n should be what? 2. So 2 to the 2 equals 4. That's 4 I really need. So the 4 here.
Yes, sir.
So if it's 4, it said the new subnet mask is what?
2
So this is group size, this is subnet, right?
Yeah.
So if it's again, you see? No, but that's not if you see. So if it's 2 to the n, so I just need 2 to create the 4 subnets. So the subnets here, 2 to the n, and I just need 2. Now these 2 may use.
Yes.
And if I add 128 to 64, it give me what?
198.
Because I just needed 2.
It's 26.
Slash 26. And that slash 26 translates to how much? What's the subnet mask?
255, 255, 255. That's 192.
They write this on 2. And remember how we get 26?
Yes, sir.
Remember we get this slash 26?
Yes, sir.
How much would I have to borrow over here so we get it?
2 more zeros, sir.
Alright then.
And that is, the one to me goods.
Bruno.
So
So we did borrow how much? We did borrow 2 of them, don't it?
yes, yes.
So this was 128
Yeah,
plus.
60.
So this give me 1.
92.
So how much is available now? How much zeros leave?
6.
Eh?
6.
1, 2, 3, 4, 5, 6. And this that is left is available. What they call it?
Post.
Alright then.
I need 50 posting.
Host per subnet.
2 to the 6 minus
No, it's 2. That formula is
2 to the n.
2 to the n minus 2 is the formula.
Also, so when it was confused, you know, the what the name of the
The first one,
no super case, yes. I never put it to minus zero super case, sir.
up here, so?
Yeah, can you look like say,
Oh, it's actually there. No, it's 2 to the, sorry. It's 2 to the n minus 2.
yes.
So it's not super, it's not subscript. It's 2 to the n minus 2. But again, how much we have leave here, so? For the host. So that is how we get the 6. We find out so that the host per subnet. So if I that would have to say if I 6 leave, so it's 2 to the 6. How much is 2 to the 6? Using a calculator. 2 to the 6 equals how much?
4.
Eh?
64.
2 to the 6 is 64?
Yes, sir, because if a minus 2, I get 64.
Hold on now. So 2 to the 6 is what? And when you add the formula now, so that is going to be 64 minus 2, which now equals
62.
So what does that tell me, say? How much votes we can get?
6. Sir, you can get
62 votes.
Hold on. Susan, this. So it really depends where you go for it. If you use the higher number of votes first, I'm more likely to all go they can get votes.
No, man, but you have to use what available. Remember the zeros are available because everything else from here so to here, so the lock off. Only how much we did borrow to get 26? 2. In that course, in that last octet here, don't it? So that means a 6 lead. So anything available are just 6 available. So we have to use that. So that when you use and put that formula, that will give it. So alright, so since it's only 2 we use. So the 2 was what? So that means a that block here we are going to use. Right?
Yes.
So watch me now. So using this same address now, which now becomes see there. So let's see this. 1.0, 64, 28. Everything else will remain the same. The 3 first object will have be the same, right? Go then get 64 for the next one. And how then get 128. Try to remember which block we're using. So that means everything must be added by so that means if you have new addresses, so that means even though you get this address, what them saying new address is 192.168. That's same address I was in here. Yes, same address. No. I'm here. I mentioned the same address I was using. I'm here. No, sorry, I was using the wrong address. Sorry. This should be 1.0. Let me use that address. But I don't want to use the 50. Right. So it's going to be 1. That one. 0. Eh?
That's 0.
1.0 is going to be the first one, right?
Yes.
Slash, we don't say slash what?
26.
So we now add that. So we know it's that. So that means my second one is going to be 192.168. That one. That
64.
64. When I add 64 to 64, how much that give me?
128.
1.128. And when I add 64 to 128, how many get?
192.
So now the fourth something like that. Why create? Easy. 1, 2, 3, 4 this.
Yes, sir.
And the fourth subject that's to create a while ago.
Yes, sir.
Just want to see it, you know. But watch the trick now. So if this is dot 0, and that's why I write this here, you're going to get a question like, so if you create 4, this is asking you to create 4 subnets, you just created the 4. So in the first subnet, 1 second. Hello? Yeah. Yeah, man, there access here. Yeah, man, should they work? Yeah, man, everybody there. Cool. Yeah, man, cool. Sorry about that. In the first subnet, right? Can 0 be used to assign to the computer?
No.
Why?
That's 0.
Well, 1, because it's 0, but because this address now becomes what you call the network address. So that means my first usable address in this range will have to be what? That what? 1. That 1. So it's going to be 192.168.1. Good. What is going to be my last? Can I use 64 as my last one?
No.
So that means any computer I'm going to assign have to be between 0 and 164. No, 0 and 64. So that means so I can't give 0 because my first usable address is going to be 1. So when you plug in and you get a computer address, you're going to get that 1. But I can't use 64 because 64 is in between. 64 now belongs to, because this is the first one, don't it?
6.
This is the first one, right? The second one, yeah. Third one. Third subnet. Fourth subnet. Can I use that 64 in that one? Eh? Because it belongs to what? And it belongs to a different subnet. So that means what will be my last address in this range?
63.62. 127.
No.
Which one, sir? Which one?
You have something called broadcast. So what will be my last address is going to be 192.168.1.63.
Yeah.
So my last host IP have to be what? That what in this case? Sorry. 192.168.1.
62.
60?
2.
60.
Oh, the first one was still on top of it.
Yes, still at the first subnet. No, man. We can't use the second subnet because I told you the different subnet. So What you now have is this becomes what they call the broadcast address. So the addresses that any computer can use is have between 1 and, but you have to get in between these two networks, don't it? Want to see that? Want to see it, but good enough. So for example now, IT needs 50 hosts. Can I use the first block of IP address to give to IT?
Yes.
Why not?
Push on to 63.
Eh?
Yes, sir.
I can because
No.
63 no more than 50.
Yes, sir. No, sir.
Eh?
No.
You know more than 50.
That's what I do.
Oh, 63 I can give. No, I can give IT what? The first block of address, don't it?
Yes, sir.
So I can say IT can use 192 dot 0 slash. Sales is 25. Yeah? The last one doesn't work because I'm not doing homework. The sales is 25. How much address we need to give sales?
Go for the same, sir. More 30, sir.
Can I get them the same though, right?
Yes, sir.
But would I give them back in the first?
No, sir. The same
Why?
one, sir.
Let us just use the second one.
Yes, sir.
Same thing for HR and same thing for admin. Admin are gonna need all of 64 IP address though.
No, sir.
Because of how much people in admin. But the point is, I have this block that I can give to admin. So if admin should expand, add more people or devices, I would have had usable addresses to give them. Yes or no?
Yes, sir.
I hope you want to see it too.
You see,
Want to see it? So this is the last thing I give them, and then I'm gonna yard after this. So make sure I see it. So this is the question.
Yeah, go back.
Me?
okay.
And I'm gonna pay me.
How much?
Yeah, you go homework, sir. We are telling you.
Eh?
We are giving back.
So, I'll get the homework, sir.
So Rose, I get that thing. They're gonna have this as a cheat sheet and the exam. You can't learn. I'm showing you how to get to this and how to add everything. So you have a question that says you have this IP address 192. So the last thing that we can go 16.5. So I'm the IT man. Strictly computer. You know? Sixteen dot 5 dot 133 slash 29. This is a slash 29. Although may I leave that up here, so. Somebody come up here and write the subnet mask under each of them for me.
That each of them?
What will be the subnet mask? So the slash 29, what is the subnet mask for it? All right, yeah, tell me. All right, no problem. So it will be
255.
255 dot
250.
255 255 dot
255. Oh.
dot what?
240.
2/29. 2. Exactly. That's how much. Oh, we get 29.
We'll get 29.
Oh, we get 248, sorry.
Cause I want.
And then the 8 block plus
Eh?
6. Give the 8 blocks there.
No, the 255 them, we just have we're not even gonna write out 80. We just have to put a big X, right? To represent the first 80, right?
Yeah.
And the second 80, because then you're dead, don't it?
Yeah.
Yes, sir.
And the third 80. So these are 1, 2, 3, 4, 5, 6, 7, 8. How much? Remember 8 plus 8 is how much?
6.
Plus what?
34.
So if we want 29, how much zero I have to take to get 29?
5.
So this not dead.
Yeah.
25,
Yeah.
26,
Yeah.
27,
Yeah.
28.
Yeah.
That's 29 that.
Yes, sir.
So this would have been what? No what?
28 plus 6 plus 32 plus 16 plus 8.
And that give me?
248.
So that means, although now you're the answer still. So how much zero left then?
3.
Okay. So if it's 3 zeros leave. Question is. Where's my question? How many total bits are being used to identify the network? That's an easy one. Easy.
29 bits, sir.
Yes, sir.
I don't have it.
29. How you get 29?
Sir, we just 3 0 we leave out of all of the A them, out of all of the active them.
And how many total bits identify the host?
29.
3. It's 3. 3. Oh, how many total bits identify the network? You are right. You get it right. 29. Oh, you said we get 29.
Oh, 23.
Hold on, man. When we did again. This should be the first set of 8, don't it?
Yeah.
This is the second set of 8.
Yeah.
This is the third set of 8.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8 plus 8, how much?
24.
So all of them are dead, right? Are used. Anything what dead belongs to who?
Network.
The network. And how much would you have to take over this portion to get 29? Eh? 5 of them, right?
Yes, sir.
So this is dead, right?
Yeah.
X. X.
Yeah.
X.
Yeah.
X.
Yeah.
One more?
Yeah.
X. No so?
So that's the bit.
That's all of them are bits, because them are zeros.
Yeah.
That identify the network.
Yeah.
Bits.
So now the 29 this make this reach 29.
Yes, sir.
So how much leave?
3.
3 leave for who?
Host them.
So anything leave must be for the host. So once you identify the network, anything left have to be for the host. So you see how much leave? So them ask how much leave for the host. That's 3. Now we say that the network is how much?
29.
And host is
And the host has to.
Alright. And we're not gonna use that, right? That'll be a big number.
Yeah.
But when the point is, we want to make sure to get, if we get a question like that, we can know how to identify the. You can do that?
Yes, sir. Yes, sir.
If we give them a last address, which is an easy one. 172.16.5.10.
The right one.
It's an easy one. I'm gonna rub out the. No, I'm gonna leave the cheat sheet. 172.16.5.10/28. Somebody come up and tell me what is the full subnet mask for this address. Somebody just come up and write. Nobody tell me, just come write.
Yes, sir, go on.
Yes, sir, page there.
Sir, man, the blue marker there, sir. Okay, thank you. The spread point.
Come on, that's the first one. What is the full subnet mask?
Cheap.
Right, 0?
Yes, sir.
What you write, that's 0?
Yes, sir.
Oh, no, it's really see put a cross in it. Incorrect?
Also right here, then, sir.
Is it incorrect?
Yes, sir.
Give me a round of applause, man, right. The last one, me I'm going to dip this now. Into that get, I'm saying I get to the exam. Very question like this for the exam. Una understand and learn something from me? And you try to impart it in a way when you can vibe it, you know. And that 192 was which class of address?
A.
A, B, C, D, or E?
E. C.
Correct. And if you get an exam, if you practice the wrong thing from now, you get it wrong in the exam, you know.
Sir, we don't say I see, man, remember I read.
That left.
192.
Yeah.
That one is the last one, 168. The easy one is again. Never know I didn't give back this one, but yeah, but that one, that's 0, right? So that's subnet mask of 255.
Yeah,
255.
255.
That 255.
That's legal.
No, that 240. First things first. This 240 is slash what?
28.
Now let's see what this. So, right. Will that be a slash?
28.
28. And don't forget that, right?
Yes.
Next word. Please list the following number of networks, number of hosts per network.
Oh. Sir, right, but the digits there. Sir, 4 was listen.
Hold on now. So the number of networks and the number of hosts we can get out of this IP address. So first of all, just give it. We're not going to go further because there's another party. But
28.
how much number of networks can I get out of this?
28.
Please, don't guess it. Somebody come up here and work
28,
out so you
sir.
get 20.
4. I'm correct, but it's here.
No problem.
Just use X number then.
You see from you say 255,
Yeah.
you can call them out as dead. So then they are X. Eight, that right? 240, right? And that 240 is a slash 28. Alright? Well, I know it is a slash 240 is a slash 28, right? Slash 28.
23.
So,
You sure what?
what are you?
8, 16, 24.
Alright.
Hold on then. It's a what? 25, 26, 27, 28. So them are dead. So how much leave?
It's a 4 glucose. But this is a pretty network. So 28. 28 is the network. I'm not ever leave a glucose.
Remember this thing. And you have to use the formula to get the amount of network, get the amount of hosts. Anybody can help with this. So somebody else work out the first part first. Number of networks. What is the answer? How much networks you can get from that address? You're on the right part, but tell me quick. Answer the right in front of you for the words.
So, like under pressure, both. Move to the end. In a little for.
That's how we are trying to find. Amount of networks. You're on the right part.
The next one is something in a seven.
All right. Now let's show you a trick. How much you count off here so to get it?
4.
4. Count off the 4 then. How much it add up to? Which one is land fund?
2.
No. 16.
So 2 to 16.
No. Count again. You count off how much?
4.
4. So if me comes from now and say 2 to the 4, how much we get?
16. 16 networks. Okay.
And you count out the 4 to the network, then you count out the 4 you count out. 16 to the and this are 1, 2, 3, 4. So the 16 that. Good. How much leave?
4.
4 leave? 1, 2, so 25, 27, 28, and it leave 4, right? If it leave 4, 2 to the 4 is how much?
16. Nice.
And the formula said minus 2 equals what?
14.
14 what?
Post.
And 16 what? You don't see it? Look, last thing.
I understand. Sure. Just the steps sometimes I'm answering.
Now we're not hard, man. Just remember. But still a seat. I've done me done enough.
I still give one more example. One more example.
Sure?
Yeah.
Example. Write down this thing. I want to see if I can get it again.
Let's see.
We're going to one last address, and that is it for the evening. Right, 200. That 138. That 1. That 0. First of all, what class address is that? Quickly.
A.
Rob.
No. B. Class C.
Thank you. Shall remember the ranges, please. So it's a class C. You have a subnet mask, which you can write underneath it, 255. Dot 255. Dot 255. Dot 252, sir. If that was supposed to be slash, what would have been the CIDR for it? Slash what?
Sure.
Slash what?
Sure.
Okay. Everybody see that?
Yes, sir.
So let's see the cheat sheet. Wow. Last, I'm the robot this one. That's that deal. Oh, we get the all right. Oh, we get the 28.
Without Madison.
255, 255, that 252, right? Oh, we get slash 28. We'll just work on that first of all.
Delete everything.
All right then. So remember now, switch slow again. So you get the address here, right?
Yeah.
From the 255, we don't send them 0 anymore. So that's an X, right?
Yes.
Yes or no?
Yes.
So how much 0 left? 1, 2, 3, 4, 5, 6, 7, 8. 252. So remember now, you know, the 138. 64. 32, 16, 8, 4, 2, 4. One needs to add up. Out of all of them numbers, they give you 252. What we need to add up? So, ready? 128 plus 64 equals how much?
192.
So them are dead now, right? Plus 32 equals how much?
124. 224. 224. Yeah, 224.
So this is gone, right? When you add 16, how much you get? 254. This is gone, right?
Yes.
But add 8, dead giveaway.
24. And then 4.
So if we want to get to 252, how much we have to add?
4.
So we get 252, yeah?
Yes.
So watch me again. 8 plus 8 plus 8 hours.
24.
So we know say
25.
26, 27, 28, 29.
30.
Oh. So we know say
I
from
think
me see that
it's
252, yeah, that means it's a slash.
30.
Please tell me when you see that. Please tell me when you see that.
Yes.
Sir. When you see that,
Okay.
that I first.
If I give one, you can't, it's not.
No, you can't do it, man. I believe that.
Exam.
So that means it's a slash 30, right? All right, so we'll get that.
Wait till exam come and see.
That's why I make sure to see that. So the question is now, so we know say it's a slash 30, right? So this is the question. List the following number of networks. That's the first one. Now I want somebody else to use. So somebody come list the number of networks.
Yeah, Elder. No. I'm love talk, you know. Love talk.
Come here, my general. So
Look,
list the number of networks. How much networks you can get out of this? So remember the formula now.
I'm betting I'm edge like I'm eating each other.
So now the formula are no one right.
No, I'm betting I'm edge every
Right,
day.
right, right, farm.
No, no. Do it. Yeah, I remember. I do it. Alright.
Anyway,
Do it to the end.
just remember, no. Watch this now. The only thing I give is
Do to the end.
for the networks. Sorry, I'm handwriting bad. Is 2
N.
to the n. And for host,
2 to the n minus
is 2 to the n minus 2. But we're not in understanding.
Third one.
How much networks can we get from that address? Remember, it's a slash 30. Boy. So if me smart, guess I'm good at it. Well, I know. No, we don't want to do that way. If you're smart, you know, just do like what we did do a while ago. But always remember, if I want to know the amount of network, from sit them here, but no say, them 255 what? Then, so X, then, don't it? First one, yeah?
Yeah.
Second one, you're dead.
Yes.
Third one, you're dead. So that leaves me with this. How much zero did I have there again? 1, 2, 3, 4, 5, 6, 7, 8. So remember, slash 30. So if you get 30, how much of them zero do you have to take with?
6 of them.
6 of them we have to get?
Yeah.
So this is how 25, 26, 27, 28, 29, 30. So 6 of them will take with. So if a 6, that means anything on X, because them 6 are now become X. And X represent the network. So if a 6, you still see.
Calculate 2 to the 6.
Remember 6 to take away, you know. So 6 now become network, you know. So I'm not just drop it in that formula, yeah, man.
2 to the 6.
2 to the 6.
That be alright.
Yeah, but you have to know how you get the tick.
So what is do this?
Using calculation.
64. I'm bearing that.
But how much now left
Two.
for the whole?
Two.
So that means if 2 to the n, which is 2 to the 6, because that is done, that part is done answer already, you know. So it would that be 64 minus. No, so?
Yeah.
Are you sure that's the right answer?
Yes, sir.
Sure.
And I man, because I use psychology for it.
Yeah.
I mean, what's another Paulos order?
Well, man. 36. How much leave?
Two.
So if I 2 leave, another post you want. Now 2 to the 2 minus 2. Oh.
That's enough.
Remember, there was 6 of them after the network, so them 6 are done use now. And just 2 left. And now we are focused on this part, the post. So anything will leave, remember I always say, once the network take it right, anything will leave belong to the post. So if I 2 leave, I will just drop the 2 one left, you know, the formula to the post. So 2 to the 2 is how much?
4.
Eh?
4.
4 minus 2.
2. The work, you know, that for this, God, these are the 2 left statement.
Eh?
And I said, them serial, the 2 left statement.
Which actually said the 2 left back?
So this is that shows, I'm like, consolidating sales.
No.
Like, when the 3 left back now, you just put that in there right there, so.
And 3 trees.
What?
3 trees 9.
No, 2 to the 3, how much?
I use the same address. I know not play, but I use the same address.
2.
Well, I know I use the same address. But 26. If it's 26,
Anton, yeah,
anybody can answer. That's the last one. Can we don't know? That's the 5. If I'm 26, what is going to be the full subnet mask now? Quick and fast. Yeah. Now, we know say that I don't have on the board already, man. 255, we done it.
Even students.
Oh, this was the last one, but they were enjoy themselves at work. Though. Remember, slash 26, you know. So, what will be the full subnet mask?
I want to supposed to be, no, 2 there.
So, right this, so that's what? Good. How much network we can get from that? Out of that address?
Yes. No, around 4.
Good. How much force we can get? Write it properly. That's the network. How much force we can get? How much of them 0 then?
Right, let's see, 6. 6.
So 2 to the what now? Yeah, 2 to the 6 is how much?
64. So 64.
That is it. That never hard.
No.
But if everybody alright, so the only thing is though, which we say now, since that is the case, right? How much you going up by in that case?
Going up.
If you're supposed to give me 4 subnets out of that, what would be the first subnet now?
But I was in mini China.
No man, that's a subnet mask.
First subnet.
Yeah.
200,
Mm-hmm.
that 138,
That one.
that one.
Well, that zero will be the first subnet we have, but that's about how much usable IP. So that is the first subnet. What is the second subnet?
That's 200, that 138, that one, that one. Hello, you.
Eh? Be the one.
Are you? I don't know who
No,
that
alright, watch me now. Use back the 25. The 252 was slash 30, don't it?
Yes, sir.
So grab out that and use back the 252. And the 252 is a slash what? Turn and got them.
Yes.
Good.
Oh, I eat.
And I so that means 252. So how much networks we can get out of that? Good. Good.
So,
Network, you know. Right? Good. Go ahead. Go ahead. Good. And how much deeper? So how much force we can get?
no. 2 to the 2 4 minus 2 4. Minus 2, yeah.
Right.
So that's a no.
All right. The full range of the first three networks. Give me the full range of the first three networks.
Over in that first thing. Really?
200, yeah. That. Mm-hmm.
Fine, going.
That 0 to 1. Yeah, go on, go on. The next one.
1, 3.
No,
62.
no.
No, sir.
The only part that I missed now. So you're right, yes, sir. But remember now, you go up by how much? No.
4.
What was the last number? 4. If you go up by 4, everything you must add
4 is
4 to it.
so.
So really and truly, what if it's at that 0, what would be the next network then? 200, that 138, that 1, that 1. 4. Right then.
Assume I want that too.
At the first 3 more.
You probably have like emotion.
And then what's the minute the last one?
Last one.
200, that.
You see what I'm saying?
I'm not simple. So that's how the answer. That's the first 3 network. And then the last part is now identify the broadcast address for the first subnet. So remember, which one is the first subnet? Good. So that's the network address. So what you're pointing at is the network address. Can we assign this 0 to anybody computer?
No.
So, and then can we assign the 4 to anybody computer in the next network? Can we assign the 8 to anybody computer in the next network? Good. So if the next network starts at 4, I would say broadcast address is what you send out. What would be the broadcast address for the first one? That's what?
That's 1.
That 3.
That's 3.
So you just write -0 to 3. So that means if me I give a computer IP address in this range, how much me can give them?
2.
Which is what? That's what?
That 1
And that.
2.
Good. So in the second one, what would be my broadcast address? Send me again anybody an IP address. How much me can give them alone?
3,
No?
2, 5, 5,
That is it, 5 and 6. And then at this, what would have been my broadcast address? That what?
12. What about 12?
Ah, I didn't ask you for 4. The next answer would have been that one, that what? No? 8 plus 4.
16, 6.
8 plus 4.
Oh, 12.
So that means my broadcast would have to be what?
7. Yeah. So all you do is just, 2.
Because you went up by as much as to get the host, as 6 of them you take. If you write up that little something, it's
So the
not
last
4.
one might go by, so
So you just go by whatever it go by. So if this was a slash, the third 20, what would you use before 26? Did I go by what?
128.
No. This is a 25.
Oh, 24. Oh,
So we have go by what? So that means we have to then add. So this would have been now that 0, then that one. Then this would have been the next earth would have been what?
And 128.
And the next one would have been what? The fourth one would have been what?
192.
What would be my broadcast address? So that means anything between 1 and
63.
can be used for any computer. What would be my broadcast address?
127.
So that means anything from 65 to
126.
can use for the computer. What would be my broadcast address?
191.
So that means what? So what we can use to assign to the host to the computer from what?
129.
To?
190.
Thank you very much. What did I see it? I need to forget them wrong. I hate that one. Let me get it, man. Let me get it. Can you change this to a slash 29? Let's change this to a slash 29, right? What would have been my new slash 29? Quick and fast. What would have been my new subnet mask then? Quick and fast. Slash 29. What would have been my new subnet mask? This same address is now a slash 29. What would have been my new subnet mask? 240?
240.
Yes? Good. Or you get that? Because what? 25, 26, what? 27, 28, 29, no so?
Yes.
That means I have to add up 128 plus 64 plus this.
Yes.
Give me what? Good. So that means I go by what now?
Yes.
So that means this now. If I go by 8, what would have been my next address? 8?
Yeah.
So what would have been my broadcast?
Yeah.
So that means we can only use from?
1 6.
What would have been my broadcast?
9 to 14.
So you get it?
Mm-hmm.
You not get it?
Yes.
I got it. You know, most of the time so they get it. So anything we put here, so you're supposed to can get.
Oh.
Can we put 32? What would have been my subnet mask now?
You know, I don't know. It's a loop. Five.
255. So that would have been, if you want how much network we can get out of that. So how much of the 0 then we use? So that would have been 2 to the? It should have been what?
128. 64.
What is it now?
28.
2, 3, 8, and 128?
Supposed to be that. 2, 4, 64.
Okay, come here and say something right. 256. How much left for the host?
0.
Eh?
0.
0?
Yeah.
You sure?
Mm-hmm.
So if I 0 left, right? 2 to the 0, how much?
0.
You sure?
Zero.
2 to the 0.
One.
Eh?
1.
2 to the 0 equal what?
1.
1. And then 1 minus 1. 1 minus 2 equal what?
1.
Are you sure?
Negative 1.
1 minus 2 is negative 1.
You'll never see an address like that. Why? I'm not left to give nobody.
Oh.
So the most can't tell me so let's see that. And no more people in. Suppose this was a slash 16. What would have been the new subnet mask then?
Zero.
I use a subnet calculator. Why I cheat the system? I don't like that, but it's alright. No man, but what would have been the new alright, what would have been the subnet mask?
Yeah,
You know that slash 16.
yeah, take out a 255.
Take off which one of them? Come rub it up, man. Like you answer something. Which one will we take off?
Some data. Yeah.
Good.
And yeah, but
Hold on now. A slash 16, you know.
16.
Good. So that means it done this one. So this would have been then that one.
Yeah.
That one.
Yeah. Oh.
Because I only what may I use up? Which how much I accept? Everything else that then. I just the two accept them I use because 8 plus 8 hour.
16.
So that means everything else would have free. So now all them 0 I go down there so free.
Yes.
What do you see the maths?
Yes, sir.
If this was a slash 8, what would have been the new subnet mask?
255, that's 0.
Murder. That means everything else I can use for what? So that means how much networks we can get out of this if it's a slash 8.
Yeah.
No.
So really, guarantee the first time?
How much networks we can get out of this address if it's a slash 8? No.
60, right?
All right. If I want 255, what that mean? How much of them 0 there?
Wow.
So that means this first one dead. That's up?
Yes.
That means 1, 2, 3, 4, 5, 6,
2 to the
7, 8.
34.
Free, don't it? 1, 2, 3, 4, 5, 6, 7, 8. Not free. 1, 2, 3, 4, 5, 6, 7, 8. So that means all of them are not free.
Yeah. 24.
So how much we get out of this? Alright, not even tricky now. Watch me now. Slash 10. What is the subnet mask then? Slash 10. Last one, I'm really going after this. Slash 10. Slash 10. What will be the subnet mask? Don't use a subnet calculator. Because that then you don't have to calculate that exam. When it's a slash 10, what will be the new subnet mask?
Slash 10. Because if you remove that.
Sir, 255
Good.
dot
255.
0.
No, man, 255.
No, man, a slash 10.
Oh, you
So if you
255 dot 255.
1, 2, 3, 4, 5, 6, 7, 8. Now that's the first 8, right?
Yeah.
The first 8 then.
Sir, that 10 cents.
So if I that 10, how much more I have to borrow for yourself to get 10?
2.
Boom, boom. So this is 255 already dead.
Yeah.
Them 2 hour.
1 and 2.
So this hour 8. So this are 9, 10.
192, sir.
Cause you got add 128 plus 64.
So 255 dot 192.
That 192 what?
You get to know.
That 192 that?
0.
That?
0.
Murder. Say I'm gonna borrow only 2, right? I remind you, this dead no, you know. I said this dead no. This is dead, don't it? Yes or no?
Yeah, yeah.
How much will it get to the network over here, son? How much for borrow over here so we get the network?
2.
2. So if I want how much network we can get, what am I gonna put whether in there for the network?
I put 2 to 2.
I'm getting how much?
4.
How much left for the host?
2, 4, 16, 22.
22. So if I want to know how much host we can get, 2 to the what?
22.
Equals how much?
How much? One exactly. I never know that shit.
Well, now I say we can get the one food.
Share check too.
2 to the 22 how much?
Oh man.
Sir, never mind, don't answer me.
So now science the calculator for the phone. So now have a good phone in the iPhone.
No,
4 million. Eh?
Samsung good.
I don't 4 million. This
2 to the necessary 22. 2 to the power 22, brother.
2
To the power 22.
that run. That's the run.
So you might get 4 million. That's a run. For
It was set up wrong.
No, no.
4 million.
Exactly.
Yeah.
Minus 2.
4 million and add.
No, stop. So 4 million, 4 million, 194,000.
Minus 2. That's gonna get the amount of what? Host. See there, we don't need no more. We can't go no further. I'm done. So, all right. So this was same address. Last one now. /21. What should have been the new subnet mask now?
Yeah, 259.
255 that 255 that.
So this is what? This is 8. So this dead too?
Yeah.
So this dead.
Yeah.
So we can just come and put X yesterday. And this dead.
Take out the 2x then.
So that means we can write back a 255 yesterday.
Yeah.
Yes.
Good. So this is 8, 16. I'm over here so now.
Yeah.
16.
17,
18,
19,
21.
Good. So how much are there?
48.
So this would have been 1.
So you want,
So this is what is it? 17, 18, 19, 20, 21. But this is going to be 128 plus
that's not motion then.
plus
And then camera.
all that equals what?
240 or 240. No,
Come on.
192, 224, 240, 240.
So what am I going to write here? So
240.
248, that's what?
0.
Good. So if we want to know how much network, how much we borrow?
5.
5. So 2 to the, how much that?
100.
25.
Sir, two to the one.
The 5th power.
Let me keep on it. What I look at.
Yeah, man, I'm done, man.
32.
32. 32. How much left after we borrow the 8? How much left?
3.
No.
Oh, 11.
Because 8 plus
3.
9, 10, 11. So that means 2 to the,
Sir, 4.
2, 4, 14, 18.
so 2 to the 11 minus
Yeah.
2.
Yeah.
So 2 to the 11 is how much?
Oh, you know, man.
2 times 2.
Eh?
2048.
So 2 to the 11 is 2.
That's
48 minus 2, which equals to?
6.
So this is the amount of what you can get. And this is the amount of
You're going.
argument done. And if them said to me right just on it. So yo,
Sir, I'm going to you up.
my one too. So if them did say, all right, how much we go by? How much we did borrow? And it's top hour?
Yeah.
So if we forget use that same address then at the /21, what would have been my next network address here, son? Eh? 8?
32.
24.
Slash what though?
21.
I don't already know what will have been the broadcast.
So you love the
Because I don't know it's only 1 to 6 that we can use. Argument done. Big up on yourself.
So you return on election.
So when you come back?
So you need to come back in.
Me?
Yeah.
Wanna get it, right?
Yeah, look one side, brother. Sir, remember something you say something before?
Yeah, I'm gonna send it to Brother Road, yeah? Thank you girls for having me, guys. Hopefully you learned something. Hopefully it makes sense. Thank you online. Big up on yourself. Give thanks and praise.
Can I never forget?
Yes,
So
sir.
you have a motion.